Alright, so in the last video we just saw we declared two functions, unique values and value counts, and we just saw how their unique values are differing, and we have a lot of text data which we need to process, and we have to work a lot on the data pre-processing. We got an idea about it. So while observing the CPU column and RAM column, so I just made few kind of observations here. So in observation we can see that if we remove GB from RAM, I can make it as an integer value. Then after now goes with memory as well as weight. So the same goes with the memory as well as weight. So over here what do I mean is in this 8 GB, if I remove this GB and I just take 8 and I make a drop down of it, it becomes the numeric value, right? So the main aim is to remove this GB from this 8 GB. So we'll be doing it. So how to do it? So we say df ram is equals to df ram dot str dot replace string dot replace. First our main intention is if we are having 8 GB, so first we will replace this GB with a white space. So when it's with white space, what happens? It becomes something like this. See over here, it becomes something like this. If this is the case and then I remove a white space, so it becomes 8 and then space. Then what I need to do is the same kind of thing I will do it with weight also. So in weight, if we go and see weight, so in weight also we have some kilograms and all those things, right? So yeah, so in weight column also, if we just browse, we'll get some kgs, and yeah, over here, so we get the kg and kg. So we have to remove those kgs with a space. So that's what these two lines are doing, and then we will convert this into an integer value. So for doing that we use the as type function which is there already in pandas. So yep, that is all this cell is doing. It's just converting this into numeric value. The categorical value of RAM and weight has been converted to numeric value. So that's what has been done over here. CVC 8 and weight becomes 1.37. so kg and everything is gone. And then we do df.info. Our main aim was to check about weight and RAM, so it became floating points and integer points. Great. So now moving ahead to the most important part of this, this was all about a little bit of pre-processing. Now comes the main thing, that is EDA, which I was talking about. So EDA, so first we will see the distribution plot of the our dependent feature, that is price. So the price looks something like this. So if we see the distribution of this is a little bit of a left skewed Gaussian distribution. So I feel this is centrally distributed. I feel this is left skewed a little bit, not completely. Let's see how the other features and things be. So plotting the counter plots of categorical variables. So in the category we have 3 or 4 categorical variables here, that is company, type name, RAM, operating system. So we'll be using Cbond to plot them. Okay, so I have defined a function over here named as draw plot, which takes in the column name. So I have defined a figure size, object, and sn.count plot, df of call, and palette is plasma, and then plt.xsticks. I want my x labels to be vertical, so that is why I have kept this plt.xsticks rotation equals to vertical, and these categorical columns I want to explore. So for column in this categorical variables, I will call the function here draw plot, and we see the results here. So we see that company and the counts. So we see that HP has almost like 275 laptop. 275 laptops are almost of HP out of 1303, and Dell has almost crossed more than HP. That's almost like 290 or 285 laptops. Same goes with Lenovo. We see that the least is with Google and LG and Fitsuji, Samsung, Vero. You can just go around with this little bit of statistics on your own. And then we have the type name, that is what kind of models are mostly sold. So we see that notebook model are mostly sold. We have the Lenovo notebook, HP notebook, Apple notebook. So notebooks are very popular in the market, in the laptop market. So it's almost like 725 and more. So this counter plots give you a very good insights about the categorical variables. So I highly recommend counter plots for categorical variables. You get a lot of insight out of it. Then we will see average price for each laptop brands. This will say is the insight that as per company the price of laptop, how the price of laptop varies. So over here, if we just plot a bar plot over here, this gives us the inflation of the company and the price of the laptop. So basically what I mean to say is, over here, if we consider this HP laptop, this tick is, you are seeing this tick, right? The above value is almost near to 65,000 mostly. So it's saying that the maximum price of an HP laptop can go up till 65,000 or more than that, maybe like 70,000. Maybe the data is not given here, which maybe there are few laptops which go up to like 1 lakh also in HP, but those models have not been released in some parts of countries, or maybe that part is not available in the data set. But according to the data set, HP laptops, the maximum price comes out to be 65,000 or more than, or like in between 60 to 70,000, and the minimum price is almost like 52,000 or 50,000. So this, the below tick says as the minimum, and this one says as the maximum. Okay, or we can say that the average also, not minimum, sorry, we can say that the average selling price, right? So Apple, if we see Apple MacBook and everything, they go more than 1 lakh, and minimum would be, and like average selling would be something near to 67,000 or 75,000, like that. Okay, we can see a lot of variation in the price in this way. So like we get to know what is the average variation of a company's laptop and what is the maximum price which a company can assign to its laptop. Got it? So if we see one Google laptop, if we see, just see this Google laptop. In the count plot of Google, if we see, Google just produces almost like 5 or 10 laptops, mostly 10 laptops, at most 10 laptops, and just see the variation in price in Google. Those laptops are more than, like, the maximum price of laptop is almost crossing 1 lakh. So you can see this part is a very varying factor in this. So yeah, this kind of bar plots also help us to understand the variation of company and their laptops. Then we see various types of laptops. We see that notebook is something like 700. These also we just saw over here. And let me just execute this. So we get the same plot, and yeah, laptop type and variation about the price. So laptop type and variation about the price. Here we saw the laptop company name and then the variation in price. Here we are seeing the type of the laptop. Type of the laptop in the sense ultrabook, notebook, gaming laptop, 2-in-1 convertible, and workstation, all those kind. So we find over here that notebook, which is most popularly, like many of the people use notebook model very much. You see a very small tick over here, right? The reason is because this is a general purpose. The people use mostly notebook, and then the price variation must not be that much in this. The price must be reasonable so that this notebook product must grow in scale. Okay, so there's something in business analytics that if there are so many people who are purchasing, or the demand of a particular product is so much, like a notebook is so much, you have to maintain a reasonable price for it. So that is the reason why you can see a very small tick over here, not too high, not too low. Whereas if you see in Google laptop over here, this gives a very good insight. Like there are very less number of laptops in a data set of Google, but just see the variation of price. It's almost starting from 60,000 and it's varying till 1 lakh or 1 lakh or above. 10 laptops starting, minimum start is 60,000, and maximum it can go till more than 1 lakh. So a lot of variation in price because of the brand Google. Okay, so we see over here in workstation also, we can see the same kind of thing. Workstation also, not many people buy workstation laptops. these workstation laptops are almost bought by people who do very high-end task, like they need a lot of computational power. So it's the count is almost like 10 or 20, maybe 20. So you can see the variation in it. So when the count is less and the effect of price and this thing is more, these attributes give a lot of insight in your data science project, right? You have to not forget this, and you have to not forget to exclude them. Maybe some people, they exclude them because they are not giving some part of it, but no, they are a very important part and they can give a lot of contribution too. So these kind of plots, like comparing the dependent variable which each of the with each of the independent variable, will give you a very good insight. Okay, then we'll go ahead and see the variation of inches towards the price. Scatter plot would do a good thing over here. So on y-axis is this and on x-axis is this. We see that 17 inches laptop, or almost like 17.5% inches laptop, they are more than, like, the price has reached more than 3 lakh also sometimes, and most of the public buys the laptop around 13 to 14 inches. We can see the crowd over here, the scatter over here. So most of the people buy around this, and that makes sense because we almost buy like nearly to 15 inches, mostly till 15 and a half. It depends from user to user, but most of the public buys in that range, and the data shows it, right? Okay, so these were some basic plots, and how the price and everything inflates the, how every attribute is inflating the price. We saw it, and in the next video we'll look more into these insights. Thank you.